Hello everyone, welcome back to my YouTube channel, JM Lectures. JM stands for Just Mary, that would be me. And today we're going to be continuing with physics Matric questions. We are on grade 12, unit 3, wave optics. And without further ado, let's move on to the question. So question number 20 states that a 632.8 nanometer laser light produces an interference pattern on a screen 4 meters from a pair of slits. The slit space is equal to 0.2 millimeters. Calculate the fringe width. And we have four choices: A, 12.7 millimeters, B, 25.3 millimeters, C, 6.33 millimeters, and D, 15.3 centimeters. Now you could try to attempt this question with mental math, but you're gonna have to do some calculation for this question. It's actually a very simple formula, but before we get into that, let's try to understand the concept behind the question. So the question is based on an experiment done by Thomas Young, known as Young's double slit experiment. In this experiment, a source of light is used. In this case, is a laser light, but let's represent this light with this little circle right here. And this light has a certain wavelength. Let's represent this wavelength with the Greek symbol lambda. Now, what Thomas Young tried to do is see what happens when light interferes. To create this interference, he created two slits, which we can represent like so, and decided that the distance between the slits, known as the slit space, will be represented by S. So when the light hits these two slits, it diffracts. It diffracts from one of the slits like so, and it diffracts off the other slit like so. It's the same light, mind you. However, what happens in this area right here is that they interfere, and a very interesting happens when these two light waves interfere. In order to view this phenomenon, or the light interference, you have to put another screen on this far end. The distance between the slits and the screen is represented with a D. That'd be the distance between these slits and the distance between these screens. So what happens is, something very interesting happens on the screen where these two lights interfere. You see a patch of light and a patch of dark, of light and of dark, of light and of dark, of light and of dark, only in the area where these two lights interfere. These light and dark areas are known as fringes, and the distance between two consecutive light or two consecutive dark fringes is represented by W, or fringe width. Now, to actually understand what happens here, well, in the area of light, let's say this little area here, you have the wave coming from one slit, that would be this slit over here, and the wave coming from the other slit, that would be this slit over here, would be interfering constructively, meaning that they are in phase, like so. So these two constructive interferences, or these two in-phase waves, creates a patch of light. Alternatively, if we were to look at this dark region, let's say this region right over here, you also have light coming from one slit and light coming from the other slit as well. However, the two light waves are not in phase, so they would look something like this maybe, and something like this. So what happens in this area is darkness. So this is how the light fringes and the dark fringes are created. There's very much in-depth detail about how these constructive and destructive waves interfere. I'll go in further detail in this concept in another video. So moving back to the actual question, we see that we have a lot of numbers, and now we actually have quantities that can relate to those numbers. We have our wavelength, lambda. We have our slit space, represented with S. We have our fringe width, represented with W. And we have our distance between the slit and the screen. Now let's move back to our question and write out what we are given. So the first thing we have is the wavelength of a laser light. This wavelength, lambda, is 632.8 nanometers. It is preferable to change all of the units into the same standard unit, so let's change this into meters by simply changing the prefix nanometers into 10 to the power of minus 9. 10 to the power of minus 9 meters. The next thing we have is the 4 meter, which is the distance between the slits and the screen. This 4 meters is D. This is in meters, so we're good. We don't have to change that. The next thing we have is the slit space, which is S, and this is 0.2 meters. 0.2 millimeters, actually. Again, we should change this into meters by simply changing the millimeters into 10 to the power of -3 meters. So the only thing we don't have is the fringe width, or W, which is what we're being asked. Now moving on to the solution, the simple formula that relates these four units is lambda over S is equal to W over D, or the wavelength divided by the slit space is equal to the fringe width divided by the distance. We're looking for the fringe width, so let's rewrite this formula in a way that we have excluded the fringe width. So we have W is equal to lambda D divided by S. Now all we have to do here is put in the values that we have. So for lambda, we have 632.8 times 10 to the power of -9 meters. We have to multiply this by the distance, which is 4 meters, and divide it all by the slit space, which is 0.2 times 10 to the power of -3 meters. Now, if you have a calculator, this will be very simple to calculate. Let's try to do some mental math to figure this out. We can cancel out this meter by this meter. We can cancel out 0.2 by 0.2 is 1, and 4 divided by 0.2 is 20. We can cancel out 10 to the power of -3. This could change this -9 to -6. So all we have left to do is to multiply 632.8 by 20. Let us move the screen down a bit so we can see that the fringe width will be equal to 12,656 times 10 to the power of -3. We still have this meter here, so we say 10 to the power of -3. 10 to the power of -6 meters. Finally, we can simplify this even further by taking this 10 to the power of -6, moving this decimal point 3 spaces in order to get 12.656 times 10 to the power of -3 meters. Why did I do that? Well, that will allow me to simplify this as 12.656. Instead of 10 to the power of -3 meters, I can write millimeters instead. So we can actually further simplify this by rounding this number up to 12.7 millimeters. And that would be our final answer. If we look at the choices, we can see that that is in fact choice A. And that is it for this video.